Hello everyone, this is Tarun from Testing Gyan. Today we are going to discuss a very important and very interesting interview problem, which is set matrix value to 0. So this is a question of array data structure. So in this problem we are given an input array with few values as 0 in it. So based on those values we have to set corresponding row and columns as 0. So let us look at this given problem. So here we are having this input matrix which is having few zeros. Okay, so based on that we will be setting up the rows and column values as 0. So like in this case the first row third column has 0. So what will happen, it will set the complete first row and third column to 0. Likewise we are having a 0 at first column and second row. So what it will do, it will set all the column values, that is the first column values to 0 and second row values to 0. Similarly we are having one more 0 at the third row second column. So it will set third row and second column to 0. So after this our output will look something like this. Okay, so you can see all the green colored are the updated values and red colored are the values which were already there and are not changed in the given input matrix. We do have one assumption here that matrix have positive values alone, that is there are not any value which is less than 0. Okay, so based on our problem we are having few solutions to solve this. So let us discuss those solutions one by one. So the first solution is the brute force. Okay, so in this solution what exactly we do, we traverse through the matrix. Okay, and wherever we found 0, based on that we traverse through that row and that column and then update those values to a negative value. That is, if we traverse through this given matrix in this solution, then what will happen? Let me write it down again. Okay, so this is our matrix. So what will happen, we will start traversing through this matrix. We will see there's a 0 in the first row. Okay, so what it will do, it will update all the first rows values as let's say some negative value -1. Okay, and all the corresponding column values to -1. Okay. Similarly we are having 1 0 here. So what it will do, it will update the corresponding row and column values to -1. Similarly we are having 1 0 here, so it will update this one and -1 and this one is -1. So you can see based on that, based on this we have updated the matrix values. Now what we will do, we will again traverse through the matrix and wherever we find -1 we will just update that to 0. So 0 0 0 0. Only this one remains, which is our expected output. So this is our brute force solution. Now the second solution is bit optimized. So we will say optimized. This is not the efficient approach, but it's better than the brute force. In this approach what we do, we create two dummy arrays, one for the row and another for the columns, like here. Let me first write it down so that I can explain it better. Okay, so here what we will do, we will create one dummy array for column and one dummy array for rows values and one dummy array for the columns. Okay, okay, so wherever we find 0, based on that we will set that corresponding index to 0 in the rows and column matrix. Okay, so here we are finding 0 here, that is the third column and the first row. Okay, so first row value we will set to let's say -1 and third column value we will set to -1. Similarly we are having 1 0 here, which is in the second row and the first column. Okay, so the first column value we will set to -1 and the second row value we will set to -1. Similarly we are having 1 0 here, which is in the second column and the third row. So the third row value we will set to -1 and the second column value we will set to -1. Okay, so that is, we will first traverse through the matrix and based on the wherever we find 0 we update the value in the row and column matrix. Okay, after that we will traverse through the matrix again, and wherever we find, like if in any one of these we find a value as -1, we will update the corresponding element to 0. Okay, so let's say we start the traversal in our first iteration, in our first iteration our element will be this. Okay, we can see both column and row matrix are having the -1, so we will set it to 0. Then for the second element, again it's we are having the -1 in both row and column matrix, again we will set it to 0. It's an already this value is already 0, so it will keep it will stay as 0 only. Then we are having this one. Here we see the column matrix is not having the value as -1, but the row matrix is having the value as -1 for this particular element, so we will change it to 0 again. So if we follow this, at the end we will see we will be getting something like this. So if we see the last value 1, okay, both column and the row matrix both are having value which is not -1. Normally if we create an array, integer array, these values will be 0 by default. Okay, so we can say these are not -1, so this will stay as 1 only. So this is our optimized approach to handle this problem. Okay, now let us see the time complexity in both of these approaches. So the time complexity for this particular approach is, we are initially we are traversing through the array, right? And we are traversing through the array, and then we are, based on the value, we are changing the row and column. So it will be big O of n into m for the traversing through the matrix, into big O of n plus m for traversing through the individual row and columns. Then again we are traversing through the matrix, which will add on to one additional big O of n into m. So this is our time complexity for brute force. Space complexity is big O of 1 only. Okay, in this optimized approach our time complexity will be, as we are traversing through array one time, okay, to update the values in the row and column matrix, so it will be big O of n into m. Then again we are traversing one more time, it will be again big O of n into m, so which will at the end will be equal to big O of n into m. Okay, so space complexity, as we are using additional spaces, additional arrays, so it will be big O of n plus m. Okay, now let us see our final approach, which is the efficient approach. So let me first write down the complete matrix. So in this approach, what we do not create any additional arrays, or we also call them as marker arrays. Instead, what we do, we consider first row and the first column as those marker arrays. Okay, so what will happen in this case? So we will the first check will be to check if there is an 0 in the marker arrays. Then we will set two variables x and y to 0 or some other value. Let's say we declare two variables, x as 1 initially and y as 1 initially. Okay, so if we see 0 in first row, then we will set x to 0. So in this case this will change to 0. Similarly, if we see 0 in the first column, we will set y to 0. So this will be our first thing which we will do. Okay, that is updating the checks for marker row and column based on if there is a 0. Then what we will do, we will start traversing through the inner matrix. This is our inner matrix, that is a matrix which is not part of first row and column. Okay, so based on our inner matrix traversal, what we will do, wherever we find 0, we will set our marker row and column as 0. Okay, so in this case, if you see, we are having a 0 here. Okay, so this will change our these values in marker row and column as 0. Okay, so after this, after the first iteration, first traversal, after first traversal, what will happen, our matrix will look something like this: 1 0 0 1 0 0 1, and then 1 1 1 0. This is how our matrix will look after our first traversal. Okay, now after this, what we will do, we will again traverse through the inner matrix alone. That is our second traversal through matrix will start. Okay, and based on the values in the marker row and column, we will update the value in the matrix. Okay, that is, if we find 0 in any of those, that is marker row and column, we will update the value in the inner matrix. So in this case, what will happen? So we are having a 0 here, so we will change inner matrix value to 0. We are having a 0 in row marker as well as sorry, column marker as well in the row marker, so it will change to 0. If any of these is 0, we will change it to 0. Similarly, for this one, we are having a 0 here, 0 here, so this will change to 0. For this one, we are having a 0 here, but not 0 is not here, but still it will change to 0 because we are having a 0 here. For this one, this is already 0. For this one, we are having a 0 here, 0 here. For this one, we are having a 0 here. For this one, we are not having a 0 here, but we are having a 0 here. For this one, again we are having a 0 here. For this one, we are not having a 0 here and 0 here. So after this, after our second traversal, our matrix will look something like this: 1 0 0 1. Okay, so now after this, what we will do, we will traverse through first marker row and marker column based on these values. That is, if check for marker row is equal to 0, then we will update all the values of the marker row to 0. If the check for marker column is 0, then we will update all the values of marker column as 0. So in this case, both the checks are 0. So what we will do, we will change marker row values of marker row and marker column to 0. So it will be 0 0 0 0 0 0 0. Okay, and our final outcome will be this one, which is our expected output. So this is our efficient approach, right? Now the time complexity for this one will be equal to big O of 2 times big O of n to traverse through the marker row, 2 times big O of m to traverse through the marker column. Okay, then 2 times big O of n into m, as we are traversing through the matrix, inner matrix, to time. Okay, which will which will come equals to big O of n into m only. So our time complexity will be big O of n into m, and our space complexity will remain big O of 1. Okay, so this is our time complexity. You can see our time complexity is same as better approach, but our space complexity is now more efficient. Okay, so this is our efficient approach. Now let us see the implementation for all of these three approaches. So we will see the implementation of all the discussed approaches. So let us first see the brute force approach or the naive approach. Okay, we can see the time complexity for the brute force approach and the space complexity for the brute force approach here. Okay, and if we expand this method, so as we discussed, right, in brute force approach, based on the value wherever we find 0, we will update the corresponding row and column values as -1. Okay, so we are going to implement the same thing. Initially, we found the total number of rows and columns. Then we started one loop for uh, row traversal, one loop for column traversal. And then we are seeing if the element is equal to 0, then we started traversing through the columns. Okay, column values, and we updated it to -1 if it is not already -1 or 0. Similarly, we updated the row values as -1 if it is not already -1 or 0. Okay, then after this, once it is done, now our matrix is having the -1 on all the places which needs to be updated to 0. Okay, so what we will do, we will again traverse through the matrix, and wherever we find the -1, wherever we find the value as -1, we will just simply change it to 0. Okay, so now let us see the working of this approach. So if you see, this is our given matrix. Okay, and this is our first method, which is the brute force approach. Now if I run it, okay, so this is my given matrix. Okay, this is the matrix how it will look like after inserting -1 in it. Okay, and at the end, this is the expected output. That is how our matrix will look like once we have inserted the zeros. Okay, so this is our expected output only. Now let us move on to the optimized approach. So you can see the time complexity for the optimized approach and the space complexity for the optimized approach. Okay. As discussed, in this particular optimized approach, we will have marker arrays, one for row and one for columns. So based on the value which we find in the matrix, if it is 0, we will be updating the corresponding marker arrays values to -1. Okay, so we started traversing through the matrix. First loop is for the rows, second loop is for the columns. Then we check if value is 0, then what we do, we update the value in the row marker array and we update the value in the column marker array on that corresponding indexes as -1. Okay, so once it is done, we have printed our array. Okay, and then we are again traversing through the array. Now this time what we will do, based on the values in the marker array, that is whichever index is marked as -1, we will be updating the value in the input array, input matrix. Okay, so we are again traversing through the matrix. Okay, then we check if that value is not already 0. Okay, then go inside and check if any of the value in the marker arrays on that index is -1, then just simply update the value in the matrix. Okay, so this is the implementation. So at the end we are simply printing it out. Now let us see the working of this implementation. So this set zeros b is the method for that implementation. Now let me run it. Now if you see, this is my given matrix. Okay, and this is how column array, that is our marker array for columns, will look like after inserting -1 in it, and this is how row marker array will look like after inserting -1 in it. And this is our final output based on the values in the marker arrays. We have updated our given matrix. So this is our expected output in this case. Okay. Now let us see our final implementation, which is for the efficient approach. Okay, so you can see the time complexity for the final approach and the space complexity for the final approach. Now in this particular approach, as we discussed initially, what we need to do, we need to create two checks. Okay, for the marker arrays, that is in this case our marker array will be the first row and column of the given matrix. So we initialize two checks. So if there is a 0 in first row, we are changing x to 0. If there is a 0 in the first column, we are changing y to 0. In our given input, these both values will get updated to 0. Okay, because we are having a 0 in both first row and first column. Then we start traversing through the inner matrix. So you can see in this case, we are starting from 1 instead of 0. So if in our inner matrix, if the value is equal to 0, then we are updating first column and first row value to 0. Okay. After this, once it is done, we are again traversing through the matrix, again traversing through the inner matrix. So wherever we find value as 0 in first row or first column, we are changing a value of the inner matrix. So if either one of those is having a value as 0, the inner matrix value will change to 0. Okay. After this, based on our check, if our x is changed to 0, that is check for the row is changed to 0, then we are updating all row values to 0. Similarly, we are based on the check for the column, we are updating all column values to 0. And at the end, we are printing our matrix. So let us see the output for this particular approach. So you can see this is our given matrix and this is our output matrix. So these are the three implementations for this particular problem. These are very straightforward implementations. We have to traverse through the matrix accordingly and update the values. So we just have to get the idea of how these approaches work. I hope you get this implementation. In case of any question or queries, please let us know over the video comments. Thank you.